Welcome to another week of In Rhythm's Lightning Talks. Again, if you are unfamiliar with me, I am Jen Crawford, and I have the pleasure of co-hosting this learning space. If you are new to Lightning Talks, each Thursday at 5:15 Eastern, you can feed your curiosity for technical knowledge by tuning in to learn from one or many of our amazing practice area consultants, grow with the phenomenal bar raisers that make up In Rhythm, and learn and grow as we go along. So this week, we're mixing things up a little bit with a panel discussion on the future of engineering that is involved with Rob, Parag, and Mikhail. This is meant to be an interactive lightning talk, so feel free to put all other work away and really make this fun and interactive. And we will have a Q&A session throughout. So if you do have something that piques your curiosity, feel free to ask throughout the lightning talk. So with that, I am going to hand it over to Rob, Parag, and Mikhail.
Hi, everyone. I'm Rob. Parag, you want to introduce yourself real quick?
Hey, guys. I'm Parag.
And Mike?
Mike.
So Mikhail goes by Mike D. So we're going to refer to him as Mike as part of this conversation. So what this lightning talk is, we're going to have a panel discussion on the future of engineering. Now, obviously, the future of engineering is an extremely broad topic, right? There's a lot of different things to cover when we start talking about the future of engineering. And so to make this really fit within our 45 minutes and make it consumable, right? We decided on 3 topics we're going to focus on. So we're going to spend 10 minutes on discussing serverless versus containers. And then we're going to spend 10 minutes focusing on cloud versus on-premise. And then finally, we're going to cap it off with Mike walking us through the exciting world of end-to-end testing, the changes that are really rapid changes that are taking place there. All right, with that said, get ready to start the timer, Jen. Rules engagement, each topic 10 minutes. Hold your questions until the time is called for the topic, and then we'll take all those questions. We'll spend about 5 minutes on questions after each topic, unless you just have a burning question you really want to throw out there. And then the biggest one is have fun. Feel free to challenge our panelists on their views, and sit back and enjoy. All right, with that, our first topic. Serverless versus containers. Let's talk about longevity and latency. So Parag, when would you choose, when you're thinking about longevity and latency, time to live with containers versus serverless functions, serverless apps, what immediately comes to your mind?
So with serverless, the function lifetime is very short, right? So the AWS Lambda functions like 15 minutes, and then Azure functions it's 5 minutes. So the shorter lifetime provides more agility, which gives developers the freedom and flexibility to push apps into the production, which are really easy to scale. As with the containers, that's not the case. Containers are always running and spinning, so they don't die once the execution is done. So scaling is not instantaneous, but that enables containers to leverage the benefits of caching. That's for longevity. For latency, as I said, for serverless, the function lifetime is really short, and there is no caching. There are no copies of functions on standby. So that results in higher invocation time. So the function will only stay warm as long as the code being executed for those few minutes. But after that, if you call them, then you face a cold start, which could face latency issues. With containers, they are always sitting there, and as soon as you send the request, they're ready for an instant response. Also, you have the capability of caching with the containers, so they can be spun really fast. So that's how containers can be advantageous in this scenario.
Gotcha. So is there a way to get around the latency issue with serverless, especially when we're thinking about serverless functions? What if we kept those serverless functions warm, right? We had a way like Mike went out and created a script that kept it warm, right, for us. And then we're starting to compare latency and longevity versus, serverless versus containers. They start to become pretty similar, don't they?
Yeah, if you come up with a way to run a script and keep it warm, then that would resolve that deficiency, definitely. Yeah.
Perfect. So what if we need persistence, right? When we start talking about something stateful, something stateless, right?
Yep.
Keeping track of what it's doing versus I don't know anything about what I'm doing. I'm going to run and do my thing, and then I'm going to spin it back down, right? What's kind of the point of stateless and stateful, between containers and serverless, right? When would I think about one versus the other?
Yeah. So just to continue the point that I said, right? We discussed the functions, the serverless, that is short-lived. So that makes it stateless. And the advantage is the more stateless functions you have, there are more ways to put them together and build something powerful, right? It's a lot of loose coupling in there. So the power of stateless computing, I would say, lies in the ability to empower the developers to write the powerful reusable functions and combine them. But then again, the downside is the lack of caching, like we said. With containers, they are stateful. So there you can leverage the benefits of caching. You can have the data cached, and reusing the cache will enable you building the new containers extremely fast.
All right, fantastic. All right, so let's move on to scalability and portability. So one of the things we know about serverless, right, is I don't have to worry about the environment. The more requests that come in, the more it scales to meet the demand up to a certain point. Obviously, there are boundaries and limits with different services like AWS or Azure or even GCP when we're talking about serverless functions, right? But then you have the issue with portability, right? Can you take something I've written for Lambda, right, and move it to Azure Functions just without making changes? Or can I move it to GCP without making changes, right? Versus you have some of the same considerations with containers, right? You can scale up to a certain point based on the resources allocated to your container management system. So whether I'm using Kubernetes or I'm using a branded flavor of Kubernetes like EKS, AKS, so Elastic Container Service on AWS, Azure Container Services, or Kubernetes service on Azure, or even GKE, right, which is Google's version of Kubernetes.
Yep.
Still run into some similar constraints, don't you?
Yep. No, absolutely. You summed it really well. Yeah, I mean, overall, traditionally, the main draw of the containers is their portability, right? The high level idea is you can combine the application with all its dependencies, package them, and run it everywhere. But now, to gain some other advantage, we use the container orchestration systems, and then there are other dependencies that we need to take care of. But that's been the traditionally main draw of containers. That's why it really powers through. In terms of serverless, again, coupling your code too tightly with cloud vendors API can make it hard to move the code from one vendor to another vendor. So the workaround would be to avoid this problem. You make sure that there is some layer of abstraction between your business logic versus the cloud vendors APIs that you're using. That will help you lessen the pain when you want to move from one cloud vendor to other vendor. But both the approaches have their pros and cons, and work around that. Yeah.
Fantastic. So all this leads to the real consideration a lot of times, in at least in organizations' minds, right? Is it cheaper and easier to maintain if I go serverless versus I go with Kubernetes? Is it worth the extra cost? Because when I think about it, if I'm spinning up a container, if I'm a container management system like Kubernetes, behind the scenes, I'm having to spin up infrastructure, right? And I'm having to dollars because I'm running infrastructure. I'm having to now maintain and support that infrastructure too, on top of my container management system, right? Whereas with serverless, it's usually pay as you go, right? Either based on the number of requests that are coming in, or based on the amount of CPU, amount of resources that are allocated for a certain period of runtime. So what would you say are typically the main considerations when you start thinking about maintenance and cost between serverless and containers?
Yeah, again, you summed it up pretty well. Maintenance is much easier for serverless applications, right? Your cloud vendor basically takes care of management of the servers and software that need to be updated. So the maintenance is pretty much less. But in containers, unlike serverless, you have to think about maintenance. They need some setup and maintenance. On the cost perspective, that's the big sell of serverless, that you don't need to pay anything unnecessarily. Only the time your code needs to be executed, the resources will be used. Unless without that, the application code won't be called. And hence you won't be charged for any compute, storage, or memory resources, right? So that's a big sell for serverless. For containers, they are constantly running. So therefore, the cloud providers are going to keep charging you for those resources, even though you're not using application at that time.
Muddy the waters a bit more, right? We now also have serverless versions, if you will, right? Fully managed Kubernetes, fully managed container systems that fall firmly into the serverless stack for all three major public clouds. So what does that mean? So when we start thinking about which one should you choose and when, right? What are your top three considerations, Parag?
Well, like you said, everything is coming together, and there are various ways. I mean, this would be an oversimplification, but as a rule of thumb, I would say choose containers when you need the flexibility, or when you need more control, or when you need to migrate the legacy services. You can go with microservices and containers, and choose serverless when you need like the speed of deployment, speed of development. You need automatic scaling, and you need lower runtime costs. So that's when you can go with serverless.
All right. Yeah. For my part, one of the things I also consider is, again, time to market, right, which is what you kind of touched on, and then what's the maturity of my team. If my team is not super mature, if my support organization is not very mature, I have a hard time envisioning using a unmanaged data management system, because there is a steep learning curve. There are many, many different wrong turns you can take. Whereas with serverless, what you see is what you get. I can build something. Yep. Sure, I may not be completely happy with certain latency issues that I may have on certain serverless platforms. I may not be happy with the inflexibility. I have to really follow specific patterns if I want to be successful leveraging serverless. But at the end of the day, I don't have to have an entire team of AWS experts, right, or Kubernetes experts to manage my stack, right? And that becomes a real dividing decision point for me. Do I have the people and the talent to support that, or do I just have really great development talent and we don't know how to do this, right? It's another kind of way of looking at it. Right, what I'd like to do is pause here for 5 minutes and take some questions from the audience. So audience, fire away. Mike, Parag, and myself, we're ready to answer.
That was exactly 10 minutes.
I have a question. What are the limitations for this serverless? Because I remember a few years ago, we had some kind of limitations for amount of Lambda functions.
So Lambda functions, you do have a limitation on how many Lambda functions you could potentially spend based on your organization limits. You can request those to be increased, right? But it's not infinite. You can't have, I couldn't push tens of thousands of Lambda functions, discrete Lambda functions out into my AWS account and my AWS org and expect that to work. I will hit my resource limits, right? You will not be able to spin up that many. You also have some limitations potentially in the number of instances of each of those functions that can be created. You also, though, have limitations in terms of how many resources can a Lambda function actually consume and for how long. And Parag kind of touched on that. It's 15 minutes. So if I have a job, I'm using Lambda, right? I'm creating Lambda to create a job, and I'm gonna run it via Lambda and use a CloudWatch event or something like that to pull it off. I have to really be cognizant of it needs to be something that happens really quickly, right? Really fast. Otherwise, I need to start thinking about other solutions, like maybe I can still use Lambda and I can use serverless, but I'm going to use a step function to orchestrate everything, and I'll break it up into smaller pieces. And I'll use the outcome out of each step within the step function to feed the next step, right? And that way, I kind of have a hybrid stateful, stateless model here that's using all serverless technology on AWS to achieve this larger process, right? But without breaking Lambda. Or I could spin up some containers and run those processes on a container.
Guys, yeah, I also have a question. So you mentioned persistence, but in my understanding, both serverless and container they both have problems with persistence. So say you have a database. Even if you have cache, it is not persistent. Your container can reboot any time. So both of them are having probably some workarounds for persistence. So which workarounds are kind of better or worse?
So I can take a crack at that first, Parag, and you can feel free to jump in and add some additional context. So with Kubernetes now, I'm speaking specifically about Kubernetes and not Docker Swarm or ECS or any derivative of that. Kubernetes has the option now to deploy persistent applications into Kubernetes, and it works from a persistent basis. It's still relatively new compared to what was previously supposed to be stateless applications, right? They could fall down, stand them back up, and you can keep moving on, right? You can also move the portions of the application that should be stateful outside of Kubernetes and run that portion separately, where you have your pods and your scale capability within Kubernetes. From a Lambda perspective, you could always save state within Dynamo or an RDS instance or even to S3. And when the job runs again, you could query that and pick back up where it left off, if you will, right? But that's starting to really break the system, I think. I would much rather have discrete Lambda functions that do different steps that are much smaller and use something like I said, like using some step functions and things like that within AWS to orchestrate those different Lambda functions based on a specific structure and based on results from the prior Lambda function. To me, that seems more sustainable and easier to maintain versus creating a hack, if you will, right, to get something that's supposed to be stateless to become stable. Parag, any thoughts on that? And that's a deep conversation, by the way, Mike. I mean, that's you start getting some real consideration, especially if you start talking about analytics applications and analytics workloads running on Kubernetes.
So I have one quick other question. So how well those two technologies can work together? Is it possible to marry the Lambdas with containers because they both can exist in the same AWS ecosystem, and probably the same with Google, Azure, etc. So
that's a great question, and actually that is a common solution, right? So you take very common short-lived functions where you don't need a full container for, and you put that functionality within Lambda, whereas the core of your app stays containerized, broken up, microservice-based or other within Kubernetes, and it talks out and offloads certain processing tasks to Lambda that are short-lived, right? Works really, really well together. But that's also similar to using Kubernetes with Dynamo or Kubernetes with SQS or any other service on the platform. And it'd be very similar in Azure as well. We're using AKS with Azure functions, right? With Azure App Service and other things like that. We are offloading and making full use of a cloud native app, right? To me, that's the power of the cloud, and that's the beauty of what we do. I don't have to build everything. I can make use of all these services and tie them together to get a complete solution that I don't have to worry about maintaining, as well as something I built custom from the ground up. I know we're probably getting close to time, Jen. All right. Any other questions before I move on?
I think Toffiger had a question in the chat. He said, do scalability rules apply to serverless, e.g. auto-scaling, load balancing, etc.?
So scalability rules with serverless is more about what my limits are, less so about what my auto-scaling is behind the scenes. Because behind the scenes, my cloud platform is taking care of the scalability for me up to a certain limit. Like I said, I can only have so many instances, and if I need to go beyond that, I have to request an instance increase, if you will. Think about it that way. Versus with AKS, EKS, and any others, you can have auto-scaling rules set up to where when the cluster hits a certain saturation, you can create another node and use DevOps processes to join it back in to the cluster to add more capacity, right? So when I think about Kubernetes, I think about capacity, whereas when I think about serverless, I think about what my resource capacity and limits are. Hopefully that answers your question, Tom.
Yeah, it does. Thank you.
Perfect. All right, moving on. The next exciting topic, cloud versus on-prem. So just a little background on this. This is a very common, even today, this is a very common topic that happens in workplaces all over the world, right? You have IT shops, having conversations with development teams, and having conversations with CFO, COO on why are we going to go to the cloud? It feels so much more expensive. We don't understand it. We can't get our arms around it all the way. And it seems really, counterintuitive to a lot of our clients, actually a lot of people I've worked with in the past. So let's start talking about why, and we'll kind of step through some of these topics around that. So first thing, let's talk about, Mike and Parag, time to market, right? Cloud versus on-prem. So what are your thoughts on what does cloud or on-prem do for us from a time to market perspective? What are kind of some of the pros and cons there?
Yeah. So I feel that in today's fast-moving digital economy, enterprise demand the fast provisioning of applications to meet targets, right, and speed up the time to market. That's very crucial. And cloud can provide these resources in a fast, flexible, and efficient way. I would say the last thing a CIO wants is to worry about whether the enterprise's infrastructure can keep up with the business demands and the innovation projects that are going on. So cloud provides a very effective answer. It's scalable, agile, and flexible, which in turn helps the speed up the time to market.
Perfect. And on top of that, you don't have to wait on, if I need to continue to scale out, I don't have to order some new blades and wait on those, right? I don't have to continue to build out my data center. But what are some of the things I lose, right, in terms of if I'm thinking of on-prem versus cloud, right? Yeah, obviously it may not be my ball of yarn anymore, even though technically it is. Maybe I have a hard time thinking about it that way, right? Maybe I have a hard time with cost control, right? Wrapping my brain around how do I control costs? Because in my data center, I control costs by determining how much I roll into that data center or how much I take out. And I've got this hardware refresh cycle, and every year things get more efficient, right?
Yes. As my question is why we have to choose when we have a nice solution in between. We have Pivotal, we have Kubernetes. You can have your cloud on premise. You can have your sysadmins or hardware guys to support the servers, and everything else is managed by your provider, but everything is happening on premises. What about that?
So that's great. It gives you some agility, but not a lot of elasticity. So the problem you still have, even if you run a private cloud on-prem, you have a fixed capacity. And if I want to add more capacity, I have to order hardware. That takes time. It has to come in. We have to get it configured. We have to get it into the data center. It has to get added in. And frankly, I don't have the ability to scale up and scale down very quickly if I'm going to need something that's outside of my capacity. So yes, if I'm doing some small things, I'm going to stay within the capacity my current data center has. Sure, that's fine. But I also agree too, there's a place for on-premise environments, right? I agree with hybrid implementations for certain things. There are plenty of companies out there that should never have a data center. They should be in the data center business. They shouldn't think about it. Even if you're going with a managed service provider, why do they need that? There are other industries where there is well thought out need for an on-premises environment where they're able to more securely store certain things, right? Whether it's regulatory, maybe there's a regulatory challenge that their public cloud provider can't meet, or there are additional security concerns where they need to have an air gap solution on-prem for certain things versus other things going into the cloud. But let's talk a little bit about elasticity, right, as we talk about that, because in my mind, the difference between private cloud, on-prem, and public cloud is your elasticity. And Parag, you want to talk a little about that?
Yes, and you nailed it from whatever you said so far. So elasticity is basically the ability to rapidly and dynamically allocate cloud resources like compute, storage, and memory in response to changing demands. So exactly to your point, to Mike, with on-premise, you end up either over-provisioning, which is allocating too many resources, or you end up under-provisioning, which is allocating too few resources. Means either you will spend up a lot more than was needed, or if you under-provision, then not all users will be able to access your service. So cloud provides you features like AWS auto scaling or Azure scale sets, which continuously monitor your application, and it automatically adjust the capacity to maintain like a steady, predictable performance at lowest possible cost. So that's a big sell of cloud over on-premise.
That's great. No, I feel like we beat that one to death. And if there's any other questions, we'll definitely take them here in just a minute. So let's talk a little about disaster recovery, right? So what I'm starting to see, right, for companies that are just starting to dip their toe into public cloud, I'm starting to see them look at public cloud as potentially a disaster recovery focus, right, to start with, and then they start moving other workloads into the public cloud. But what are some of the pros of using public cloud for disaster recovery versus relying on a colo or a warm offsite or whatever we want to call that, right, from an on-prem perspective?
Right. So yeah, like you said, on-prem disaster recovery center, they need huge investments, right? You need data center space. You need there are operational costs related to power, cooling, the site maintenance, connectivity, servers, and then you need manual operations to start the operations at the DR site. If the connection between primary and the DR side fails. So this could result in time lag to recover your application, data loss, as well as resulting in business continuity. In contrast to that, the cloud DR service, it offers a cost-effective alternative to these traditional recovery methods. It makes it easy to replicate the data in multiple locations. It could be in your surrounding areas that are called zones, or it could be in a complete different region altogether. But then it helps your business to get up and running faster in event of cyber attack or any other kind of disaster. So I would say it creates a lot more scalability and flexibility in terms of where and how much of data you want to share offsite. And it also frees up critical resources like your employees. You don't need them to take care of it. Your cloud vendor will take care of everything, and it will get you up and running in no time.
That's great. No, that's a very good explanation. So let's talk a bit about security. So this is really where, you know, the legacy corporation comes in and says everything has to be on-prem because the cloud's not secure. Well, what do we say to that, Parag? I mean, my view typically is most of the clients I've worked with, right, and in my career, they were not the most secure with their data centers either. Their data security and practices were not always the best, but where they were comfortable was they had these global controls that they put around their, and what we called it was their ball of yarn, right? They knew exactly all their networking challenges, but they had these control all the ingress egress. They knew exactly what was happening. So they recognized that the security practices within the network were not always the best, but they were comfortable with it because they've been managing it for 15 years as is, right, with these global security controls. And all of a sudden, someone wants to bring cloud into the mix. And those tools that they're used to using aren't really made for managing cloud, are they? And so now we start having this understanding gap a little bit. But what do you think, Parag? I mean, my perspective is cloud can be as, if not more secure than your on-premise environment. On top of that, you were backed up by 5,000, if you're talking AWS or Azure, of the world's best security professionals.
Yep. No, I absolutely agree. And I experienced it in my recent work projects as well, moving to cloud. So yeah, exactly like you said, on-premise, the data security is in your hand, but at the same time, it's much more manual process. You need to take care of it. You have all the responsibility. You need to make sure that you're securing your data. I mean, for some companies, it's a okay. For some companies, this is a big positive, but whilst not all the companies, not most of the companies will have expertise to secure their network, right? So on cloud, the security is the responsibility of you as well as the enterprise, as well as the cloud provider. So there is less of a burden on your IT teams, and you get all the bells and whistles, all the latest security tools that these cloud providers provide you.
Guys, can I be the devil's advocate? So the first word is just one word. It's very provocative, but just one word, parlor, that was kicked out of Amazon just recently. So basically all your data, everything is kind of protected by the user end level kind of agreements that have a lot of fine prints. Anytime you can be kicked out of Amazon, yes, or any other provider for political reasons, for other reasons. This is one question. And the second question is, what about data breaches? So if somebody want to target you specifically, and you're a very small company, maybe you don't want to, nobody knows about you. But if there is massive data breach in Amazon or Google or something, then the hackers have access to everybody, and just because this information is available, will target you specifically.
No, not exactly, Mike. So when you talk about the public cloud, right, different tenants, right, are logically isolated with encryption between data. So Amazon can't get access to your data, nor can a hacker that has access to Amazon. You have to have those keys to key in order to access it. Typically what ends up happening for most data breaches is someone left the door open. Whether that was a port on a Bastion host they shouldn't have left open, or it was a port on another PC, or an instance sitting up there in the cloud, if someone used that to gain access, they over permission these instances, right? And so now all of a sudden, once I get control of the instance, I get keys to the kingdom. I can do whatever I want. Or the most silly, right? And this is great. They check in their security code, their security keys, and their access key and security token into GitHub, into a public repository, and everybody has it. Guess what? There's bots out there that do nothing but 24/7 scan through GitHub looking for access keys and secrets, so they can go and get control of your environment. The worst one I saw was actually the SolarWinds breach recently. Companies were breached because they used the default admin password for a cloud service. Think about that. Whose fault is that? That's really our fault, right? As users of technology, we didn't follow the best practices. I think what Parag was saying is, with a shared security model, if you follow the best practices, and where you're not sure, get help to follow the best practices, you will have a completely secured environment. Whereas if you ignore the best practices, don't follow the best practices, or as you were alluding to Parler, violate terms of service, all bets are on. You're exposing yourself to risk that you can't mitigate. All right, we're going to move on real quickly. Cost for cloud versus on-prem. This is a very complex topic. It almost requires its own session. What I will say is, typically with on-premise, you're looking at electricity costs, you're looking at additional manpower, you're looking at facility costs, right? Cost per square foot, fire systems, cooling costs, and then double backbone, internet connectivity, if not triple backbone, right? Really high costs are fixed and ongoing. With cloud, you have a variable cost. You can control your costs based on the services we use. You can also control your costs based on leveraging prepaid for instances versus on-demand versus spot type instances across all three clouds. The biggest challenge is you have to look at your cloud usage over a 7-year period of time, or whatever your hardware refresh time period is for your organization. So if you refresh hardware every 7 years, you have to take that hardware cost plus your electricity cost for those 7 years and your facility cost, and use that to compare versus your cloud spend for the same type of environments. If you just look at it from an electricity perspective or just a hardware perspective over a year versus a year in the cloud, you're not providing an apples to apples type of comparison. So when it comes down to which one you should choose on cloud versus on-prem, this is one where I actually think you should choose, right? You either an organization that can really work well from a public cloud perspective, or you're an organization that can benefit from having public cloud while maintaining your data centers for specific things. I think there's a good balance to strike. However, if you're a brand new organization, if I was a startup, I wouldn't even think of having a data center these days. If I was a modern digital product company, everything I would do would be in the cloud, right? I would not even think about having a data center. All right, let's start at the Q&A because I know we're over time. We'll probably have about 3 minutes for this one. And I know we took some questions already, but I'm interested. This one sounds like a hot topic. Fire away. All right, now I'm disappointed. Mike, you gonna
go? Well, I mean, when you're, talking about security, I've had to work with a couple of customers before that have had such high security that you know, they don't even let your cell phones and stuff like going in. Those people make sense, right? They've got such super secret data inside their data centers that, you know, you can't even bring in your own laptop, right? There's just nothing that you can bring into the system that they'll come somewhat just short of a strip search before you even walk in to make sure you don't have technology. Those guys have to have on-prem. But yeah, you're completely right. Nowadays there's you've got a question on whether or not the customer or the, you know, the company understands you know, the value of having to host all that stuff internal and it completely secure and stuff like that. Now, the one other thing that I don't remember who brought it was, but the hybrid approach. You know, one thing that we have out there nowadays is a data center in a box. I don't know if y'all seen any of that technology, but long story short is, you know, a semi truck comes up with a self-sealed container, and there's just basically a big plug-in at the end of it, right? And you got to have a special hookup and all that stuff. You never actually go into the data center. The data center is self-contained and all that stuff. And so there's a lot of options out there, but as far as security goes, you're 100% right. You've either been doing it forever and you know every single bit that's going in and out of your business, or you know, you're kind of new to the game, new to the internet world, and you're not quite sure. So being in the cloud actually might give you some benefits over trying to do it all yourself.
And we're at 1 minute.
Most companies I work with can get tremendous benefit from just getting agility and flexibility in the right areas, and using a mix of public clouds, right? You can get that agility and flexibility, especially if you are a product-based company, or you are a company that has to have a lot of custom applications that you're running internally, right? You also, another way to think about it, are you a company that runs a lot of, we consider infrastructure as a service, right? So you're running a lot of VMs with a lot of installed software on there that could be potentially changed to platform as a service instead, and you start getting the economies of scale at that point, right? But I agree with you, Mike. There are many organizations that require a hybrid, and they will for a long time. I do think, though, with the trajectory of the modern public cloud, eventually, for most companies, I think eventually your data center just be a thing. Eventually, right? Just like, you know, you don't have a dial-up modem anymore, Mike. Now you've got a fiber going to your house, right? Things eventually fade away, and that's one thing that I think will happen, just due to cost.
The one exception I see to that, I don't see how they'll ever overcome it, is manufacturing.
We'll talk about that. That sounds like a great, excellent next lightning talk, Mike. I appreciate you volunteering. All right, we're going to move on. This is Mike D's specialty, and I've been looking forward to this one. All talk. We're going to talk about end-to-end testing, the changes, the history, and where it's going. And I'm going to turn it over to Mike. Mike, this is yours.
Okay, so our first thing that I want to discuss with you guys is there is a lot of misconceptions about the testing, the testing of websites, of mobile applications, or testing of the front end. It's very usual to see in the resumes the things like UI/end-to-end testing. So first of all, I want to a little bit kind of argue with this. So end-to-end testing is when you are trying to test your whole system, the system as a whole, from the user perspective. So you are emulating the real user. You are trying to start with creating data, then going through all the workflows, make sure that every user persona can actually do what they are supposed to be able to do in your application, have the right data, don't have any problems while entering it through your user interface, etc. From the other hand, for a very long time, there was only one player on the both end-to-end and user interface arena called Selenium. So Selenium is there for already 20 years. It came to as kind of contestant to the very legacy vendor solutions such as Quick Test Pro or Test Complete or even Rational Unified Test. I don't think that everybody even remember those names. But for that time, it was very revolutionary because it is, first of all, open source. And second, eventually it got support from all the browsers out there. So what Selenium gives you, it gives you ability to interact with your browsers and do things there. But the question is actually if you want to test your components, for instance, your React components, or you want to test how if basically you have a web page and you have a server backend. You are not interested in the server. You believe it will give you the right data. The question is, are you able to properly display it? Okay. So to do it, you don't need the end-to-end. So what is the difference between end-to-end tests and all the lower level tests? It is basically, first of all, it's latency. The end-to-end tests are much more slower, that they are much more fragile, easy to break, and most of all, the data management, because you are using the real database. If you don't need it for end-to-end to do the user interface testing. You don't need end-to-end. But this is what was happening for quite some time for the last probably 20 years. Or the people were called the component tests. The UI component tests were really the unit, very low level unit tests that were not even executed in the browser. This is the other kind of side of the problem. In this case, you are not able to test actually the UI. You are calling it the component test, that basically you are not able to test those components. So this is the answer to the question, is end-to-end and UI testing different? Yes, they are. But for a long time, they were using the same instrument, Selenium WebDriver. And frankly, developers were pretty uncomfortable using it because it's new for them, because it's a big learning curve. And also, again, it is very heavy. It is really heavy, the end-to-end tests. Running the end-to-end test for your application for some single test case takes 5 minutes. Who have this time during development? So this is why there were special guys called test automation engineers who were actually in charge of all the testing, UI, end-to-end, etc. It was not a developer business. So what is changing is basically so this is the answer for the question, whose business is end-to-end and whose business in the UI testing. In my personal view, the UI testing is up to developers and designers. So designers should at least do the manual testing and I mean, tell from the design perspective if everything implemented correctly, and the developers should write the UI test to make sure that component behaves how it's supposed to be behaving in a browser. The end-to-end testing is something more of business level testing. It's something that you are doing. It's basically a demo. It's like a demo. So it is how you test your high-level acceptance criteria. And usually it is the business product owners who come up together with a team with acceptance criteria, and it is SDETs who help writing those scenarios and who can do it efficiently. So do you have any questions by this time?
So Mike, I've had a couple of questions, or at least one big one. So would you consider end-to-end and UI testing critical to saying I have complete code coverage of my application?
Absolutely.
So as much as I've got unit test for everything, we're good to go. They're only what, 50% covered, if that?
So there is a test pyramid saying that the very classical metaphor saying that the most of the tests you should have is a UI tests and where the unit tests, and when you're going up to the service level tests or API tests, contract tests, and then end-to-end tests and high-level integration tests, the fewer ones you have, but more critical they are. Because if it doesn't work, it is a total disaster because they're usually testing the key workflows that users are doing.
So at the end of the day, does this help us really achieve that velocity number that we all want when we're building products? I mean, this, to me, this sounds like when we do this well, and we do this holistically, we truly are capturing our velocity and we are moving very quickly, production ready code, out to the masses.
Well, I'm not sure I understand the question.
If I have a team that has a lot of unit tests on their code, but they're not doing a lot of UI or end-to-end testing, right? They don't have a good coverage there.
Yes.
They're building things. It goes through a manual QA process. They still have a higher incident of bugs being released than, say, a project that has good end-to-end, a good mix of end-to-end and proper UI testing, correct? And so,
yeah,
I look at my
the problem.
Yeah, I look at my box as defect-free code, less defect code, right? And that's my true velocity. This helps me get that velocity boost and not have to put more work to do rework.
So basically end-to-end, you cannot release reliably things without any end-to-end testing.
Right.
Would it be manual checkouts? Would it be automated? But you need it. If you don't want to invest in UI tests, it just means that your tech leads will be doing manual checkouts before like your releases, which is probably what is happening in for our client, for instance.
Right.
So one day the entire team is doing the only one thing. They're doing manual checkouts. And by the time they do it, nothing works. So they are trying to integrate hastily everything. And while they are setting up the environment, they don't have time to actually do that manual testing, etc. And this is why CI/CD, because you are continuously, it is really great having your UI tests and end-to-end test as a part of CI/CD, so that all the time you have an application that is ready to be deployed, at least you believe so.
That's great. Tell us about some of the new technology in that space, Mike.
So again, for the very long time, there was only one player there called Selenium WebDriver. What's good about it is that it is W3C standard, and all the browsers implement it, and all the browsers and even the mobile applications can be tested with WebDriver. Also, you have plenty of players like BrowserStack or South Labs that provide you on in the cloud solutions to run your tests. So basically, you are using their devices, they set up their virtual machines and the browsers installed there to run your tests. And you cannot have it with any other tool yet. So Cypress, for instance, the new kid on the block and the very exciting new technology, it is currently only support Chrome and Firefox and Edge, because Edge is basically Chrome. And that's it. Still, if you wanna be able to test everything, it is still Selenium. So from the other hand, as you all know, the statical coded, statical typed languages like Java and C# are a little bit kind of losing popularity to languages like Python and JavaScript. Selenium was popularity is very much based also on their Java support. From the other hand, if you want developers to be able to write UI tests, front-end developers, you want them to write it in the language that they are familiar with, which is JavaScript, the same language that, or TypeScript, the same language that they use for their actual production code. So this is why the last 3 or 5 years, there is a real kind of hype around very different solutions to write end-to-end and UI tests in JavaScript. This is what enables your developers doing it. And especially it is enabling your developers writing the quality UI tests, which mean that they are running faster, much faster, and you have even fewer end-to-end tests, because your end-to-end tests are not coupled with UI ones. Your end-to-end tests is just checking that you can do the entire flow.
Smoke test.
So the last, what?
Would you consider that kind of more of a smoke test? At the end of the flow?
For end-to-end flow, it is still WebDriver, in my view. So, and especially, and talking about JavaScript, it's WebDriver IO, which is very much also have an API that very much resembles jQuery, which is something that every JavaScript developer is familiar with, which is pretty simple. They have just 2 variables, $ and browser, and that's it. And those 2 objects give you all the functionality you need. Getting the elements is very easy. You are just using XPath or CSS or kind of tag or whatever, and it will understand it. Also, it can use either WebDriver under the hood or the newer technologies like Chrome DevTools protocol.
Okay.
And use a Puppeteer under the hood if you want to. Yeah, in my view, way to go if you are writing UI tests, the component tests, go with Cypress. If you need end-to-end tests, do the WebDriver IO. You can do this in the same time. You don't have to select between 2. You can have developers writing UI tests and the end-to-end tester, the SDETs or QA engineers writing your end-to-end tests. And this is, I had an experience with that. For instance, in MasterCard, we were doing exactly that in Alberta project, and it was working pretty well, I would say.
That's fantastic, Mike. Let's go ahead and move on and take some questions. It sounds like we probably have a few.
Yeah, just a question. You were talking about responsibilities. So who should write which kind of test? And what I see from my experience, that more and more test writing are responsibilities of developers, and it seems as that developers just writing kind of end-to-end test, because as you mentioned, MasterCard. They are writing unit tests, functional tests, integration tests, PAC tests, so almost everything, just except end-to-end tests. And what is your vision regarding whose responsibility, which test writing?
Okay, this is a little bit different kind of questions, because it goes again, what is the role of SDET? I had a pretty big talk on this. I hope there is a link to that in the last slide. But overall, the SDET are the guys, in my view at least, and how it generally currently where it is going to. The SDET are guys responsible for vision behind ensuring the holistic quality in your product. So those are the guys who can tell you what you are not doing that you should be doing, that can help you fix how you do unit tests, tell you where you have a gap that you need to fill, how you organize your QA process more efficiently, from architecture standpoint, from process standpoint, from the things like CI/CD worked with DevOps guys to make sure that you have efficient pipelines, ensuring that you are testing, doing the proper tests on every step. Who is writing the tests per se? Well, it's the question who you have, how it's the question to your organization. In my view, it doesn't matter too much as soon as developers are writing unit tests and component tests.
Just real quick question to add on to that. So my experience, a lot of developers don't seem to write very good tests. And so what would you recommend to kind of improve the quality of the tests that our development teams write?
Yeah, so again, returning to Alberta project in MasterCard, what we had a whole team of SDT, like a separate agile team, whose responsibility was to support frameworks, to create examples to how to of the tests, to start kind of do the pilot testing projects that they further hand over to developers as an example how they do things. And then they also were responsible for reviewing each and every merge request from each and every team to make sure that they have proper coverage, that proper testability, that all the tests that we decided that need to be there are there. And if they are not, we can discuss every case separately. Why is it so should it be there? Or probably in this case, we may omit them. So this is how it worked in MasterCard. Developers were, I'm not sure that they were very comfortable, but we were able to meet the very hard deadlines, even with this seemingly pretty heavy process.
Fantastic. Next question. All right, Mike. Well, I guess you were extremely thorough in your explanations, because not as many questions as I thought there were going to be. But this is a problem that we also encounter regularly, right? And it's a lot of times it's something we're asked to fix. And again, this is something that we're more than happy to have those conversations about, right? Especially if it's something that's impacting true velocity and quality within your product.